Hello, and welcome to the Chemistry Solution. This tutorial is on assigning oxidation numbers. Oxidation numbers are a bookkeeping system used to keep track of electrons in a compound. All bonded electrons are assigned to a more electronegative atom. Remember that oxidation numbers are not real charges on the atoms. Let's go over some rules for assigning oxidation numbers. First, the oxidation number for any lone element is 0. Some examples would be potassium or aluminum, but the oxidation number is also 0 even for molecules composed of all atoms of the same element, like O2 or S8. Oxidation numbers are usually assigned to the most electronegative elements first, which means that the oxidation number assigned to fluorine is always -1. The oxidation number assigned to oxygen is always -2, except when in a compound with fluorine. Oxidation numbers are assigned based on the ion they would form, using the group number on the periodic table. So elements in group 1A and 2A would have oxidation numbers of +1 and +2, respectively, and aluminum is assigned an oxidation number of +3. And generally, the oxidation number for hydrogen is +1 if combined with nonmetals, and -1 if combined with only metals. And lastly, the sum of the oxidation numbers of all the atoms must equal the overall charge on the compound. Let's look at some examples. Assign oxidation numbers for all of the elements in the following compounds. Looking at our first compound, OF2, we know that we need to assign the oxidation number for the most electronegative element first, and that would be fluorine. Fluorine has an oxidation number of -1. But there are 2 fluorine atoms, and so when assigning oxidation numbers, I like to keep track by writing the oxidation state right below the atom in the compound and then multiplying it by the subscript on that element for a total of -2. Now remember that the sum of the oxidation numbers must equal the overall charge on the compound. So for OF2, the sum of the oxidation numbers must be 0. This means that oxygen must have an oxidation number of +2 because +2 and -2 equals 0. So in this compound, fluorine has an oxidation state of -1 and oxygen has an oxidation state of +2. Moving to the next example. Again, we assign the oxidation number for the most electronegative element first, which means that oxygen has an oxidation number of -2. You could also determine this by looking at where oxygen is on the periodic table and remembering that oxygen normally forms ions with a charge of -2. Again, I write the oxidation number right below the atom in the compound, and then I multiply it by the subscript on that element. Here we have 3 oxygen atoms, each with an oxidation number of -2, giving us a total of -6. Remember that the sum of the oxidation numbers for all of the atoms in the compound must equal the overall charge on that compound, and in this case the overall charge on the compound is 0, which means that the sum of the oxidation numbers for iron must be equal to +6. Now looking at this compound, we have 2 iron atoms. This means that the oxidation state on each iron atom must be +3. So +3 times 2, which is the subscript on iron, gives us +6. And +6 plus the -6, which is the sum of the oxidation numbers on the oxygen, equals 0. So in this case, oxygen has an oxidation state of -2, and iron has an oxidation state of +3. Looking at our third example, remember that hydrogen normally has an oxidation number of +1 when combined with nonmetals. When we multiply this oxidation number by the total number of atoms of hydrogen in the molecule, this gives us a total of +4. Remembering that the sum of the oxidation numbers must be equal to 0 for a neutral compound, we know that the oxidation state for carbon must be negative.